It is no secret that our climate is drastically changing and on the path to becoming uninhabitable. Our temperatures are spiking, natural disasters are increasing, and the air is becoming toxic. This is from humans' horrible habit of pollution. We are solely responsible for the extreme pollution of our air, water, and land. If we continue these bad habits, we have roughly 60 years until the Earth is no longer able to sustain life. But when this happens, we have a plan.
In the 1930s and 40s, Nazi Germany found out the possibilities of using long-distance rockets. After World War II, the United States and Soviet Union found their data and started their own missile programs. On October 4, 1957, the Soviets launched the first artificial satellite into Earth's orbit. 4 years later, on April 12, 1961, Russian Lieutenant Yuri became the first man to enter Earth's orbit. His flight lasted 108 minutes. In the 1980s, satellite communications were sent into orbit around the Earth for the very first time. In November of 2000, the very first people were sent into the International Space Station to run a series of tests to further understand space. This crew was known as Expedition 1. Now, for the first time in human history, we are sending colonies of people into Earth's orbit indefinitely.
I think it's important to explore space to get a better understanding of how special Earth is, to understand where we are in our universe, where we are in our own galaxy, and how rare it is to have the life that we do have. Space fascinates me. I think it would be cool to go on that kind of an adventure.
People get to the settlements using multiple different reusable rockets. And so these rockets will bring up different groups of people to different settlements, and then they will be able to return back to Earth and then take other people up. So that means that we won't have to use as many materials to build rockets. And then once everyone's up into space, we can disassemble the rockets and use them to create other parts for our settlements.
To grow food, we will be using aquaponics. Aquaponics is a way to grow food with water instead of using soil. The plants also share their space with fish, which are in charge of fertilizing the plants. The fish are salmon and sardines, so they can also be eaten to maximize their sustainability. The food that we have is the most nutrient-rich foods so that people in our settlement can get their needed nutrients without overeating.
Altogether, our settlements hold about 6 billion people, and that is then split up into 20 different settlements, which each hold 300 million people. And in each settlement, we have 10 different pods where people will be living. So that again will be split up, so it's 30 million people in each individual pod. When we were designing our settlements, we found that each person needs about 200 square feet of space to live comfortably. Everyone is going to have a bed or a sleeping pod that can also double as a place that is just personal space, because I think everyone needs that, of course. And then you also have to have other living spaces, for instance, like places to cook, places to be entertained, etc. So we are going to have those be public, as well as bathrooms.
Our water production follows the same system that is currently in use on the International Space Station. This is called the Sabatier process, which recycles the hydrogen and oxygen molecules from the air. Then a machine called a nickel catalyst combines them at very high pressures and temperatures in order to create water. Our settlement will also reuse as much water as possible using treatment plants to clean wastewater.
How do you create artificial gravity in space?
One way you can is using centripetal force. So if your space settlement is spinning, like this bike wheel, and imagine that you are an ant inside this bike wheel spinning with it. To you as the ant, it's going to feel like gravity as you're getting pulled outwards, and you'll be able to walk along on the inside of it. So the two most important variables that you're going to want to keep an eye out for are how fast you're rotating and how far you are away from the center. So the further you are from the center, the faster you're going to be moving and the greater your force of gravity that you're going to feel. As you move towards the center, you're going to feel less gravity. One way that you could deal with that is if you had separate rings and the inside one was spinning faster, to make it feel like you had a similar gravity to the outside ring.
In other words, our space settlements will have gravity because they'll just be spinning really fast. We'll maintain this motion indefinitely by using nuclear power to power the motion. And then once we have collected enough solar power using solar panels, we will switch to using only solar power to power the settlement's rotation. Our settlements will each be orbiting Earth at 354 feet above the surface, which is 100 miles further away than the ISS is right now. We chose to orbit Earth for two main reasons. While the settlements are being constructed and prepared to launch into space, people will be able to live inside the pods on Earth's surface. Each housing pod will be 1,518,750,000,000 square feet. The specific dimensions are a height of 2 miles and a diameter of 5 miles. The pods will be made up of 300 concentric rings. The rings will have 40-foot tall ceilings and a 2-mile span. The agricultural pods will have the same diameter, but will have a height of 4 miles to maximize farmland acreage. There will be 200 rings in these pods that each have 60-foot tall ceilings to maximize airflow and plant growth. There will be fixed elevators in each ring that will be able to transport people from one ring to another and also into the shafts to travel to other pods.
Using our knowledge from the past, we are creating settlements that will orbit Earth and sustain life indefinitely. Even though we have a way to escape our steadily deteriorating world, it is also our job to save it. If we start now, we may be able to reverse this horrible path that we are on and save our Earth.